Okay, so, you know, well, a lot of things. This is stuff that we have kind of talked about earlier in this course. Remember we said that within the troposphere anyway, as you go up in the troposphere, wind speed increases. And we said that actually uh, weather folks prepare these upper level maps of what the wind is doing or what the air is doing at upper elevations called isobaric maps. And we're going to see examples of some isobaric maps. Now, they are drawn at a particular, what do I say, pressure, atmospheric pressure. So 850 millibar isobaric maps are drawn to show heights or elevations at which the pressure is 850 millibars. In contrast to that, we have 200 millibar isobaric maps. And now, one of the things we know that in order to get to find an elevation or an altitude at which the atmospheric pressure is 200 millibars, we would have to go up, right? So the 200 millibar isobaric map is an upper elevation, whereas the 850 millibar isobaric map is actually our lowest level, our closest to the Earth's surface isobaric map. Now, the way we get these maps, these layers, what, vertically speaking, what is happening in the Earth's atmosphere is to send up those weather balloons twice daily, 6 a.m. and 6 p.m. The balloons go up. So now in this chapter we're talking about weather prediction and actually what we call the vertical profile, or what the air is doing vertically is definitely a player as to what weather conditions we can count on in the future. And we've kind of talked a little bit about this. For instance, we talked about zonal flow. Remember, that's where there's not much waves at all. And zonal flow without the kinks tends to have kind of persistent sort of weather. There's no kinks to make our surface low and our surface high pressure. Meridional or wavy flow, on the other hand, do create those cyclones and anticyclones at the Earth's surface, and you can kind of expect some sort of dynamic weather, perhaps. So if anybody asks you, or if you look on the weather map and you kind of see that wavy flow, you should find your ridge or your peak, and that's a little bit downstream from that. That's where your surface high pressures are going to be. If you find that low point or that trough, that's where your surface low pressure is going to be. Generally speaking, we have clear skies around a high, potential for cloudy or precipitation around a low. So these are 850 millibar isobaric maps. So these would be the lowest, showing you the conditions that are closest to the Earth's surface. Okay, so we can, meteorologists can use these to kind of get a sense for how systems are going to be steered. And looking at trend forecasting, they can look for, you see they found the trough, look for a cyclone or a low at the Earth's surface, that sort of thing. This is showing you that actually here in the mid-latitudes, well, even at all elevations, at all latitudes, a certain elevation, the wind is going to go from the west towards the east. And so along those lines, we have cold air convecting here, associated with the trough, and warm air convecting or moving at the Earth's surface here, associating a kind of a ridge feature here. So a 500 millibar isobaric map would be basically stepping it up, going in up a layer in the Earth's atmosphere. So here this is actually at the same time, and it's showing you again the influence of, or you can see that surface low pressure there. This is the highest of the three isobaric maps I'm going to show you. And notice here we kind of can still see our ISO heights showing us that low at the Earth's surface. Now the pink here, actually at upper elevations in this isobaric map, is showing us that the jet stream. And the jet stream is definitely a player in steering systems, weather systems. And not only that, but the presence or the absence of a jet stream can definitely influence specifically severe weather. For instance, and this is actually kind of going back to something we talked about earlier, if the jet stream is relatively strong, a few things that can intensify central lows, and that can intensify our mid-latitude cyclones. Strong jet streams can also strengthen our thunderstorm cells because they provide for these tilted thunderstorm cells. I don't know if you remember the majestic straight up and down versus a tilted thunderstorm cell. Strong winds aloft or a strong jet stream can go ahead and tilt your cell so that it lasts longer and can be more severe. I don't know if you remember this too, but with regard to the jet stream and as it relates to hurricane activity, actually a strong jet stream messes up your hurricane, so it will diminish hurricane activity. A weak jet stream, on the other hand, will cause storms to move more slowly, and they will strengthen hurricane activity. And a weak jet stream, then you would expect your thunderstorms to be less severe and less likely to have, less severe. So this is showing you kind of the movement of a weather system. Particularly, actually, we have a cyclone and an anticyclone kind of moving through the area. And as we watch these, the movement of the wind in upper elevations.